It's not bad until you get woke up at 2:30 in the morning because the propane tank ran out and I had to switch tanks over.
Oh no.
Not good. Well, my hex beam survived this thing, so I'm good.
You know, it's a good thing. I was concerned when I looked out there, what was it, Thursday night, I think. And yeah, it was like forming ice on the tree first, and then the snow was sticking to the ice.
Yeah, but as Jim said, there was no wind. I think that's what nailed me last time.
Still, I went out Thursday night and knocked a bunch of snow out of some of my trees.
If you just keep your antennas in the attic, you don't have to worry about that.
Yeah. Well, that's where I have my antennas, except for one vertical out in the backyard, and it doesn't collect much ice and snow.
Yeah, well, the attic doesn't work all that great either sometimes, so it's a compromise.
It is 9 a.m.
Well, I guess we better go ahead and start. First time I've seen myself on this thing. Let's go around and see who you are. Who are you folks here?
Roger,
K7CTM Firestone.
By suffix or something, so we just don't get 30 people all at once.
Or open the participant list and read yourself down. Oh, no, you can't because you're always at the top no matter what. Never mind. I'll stop helping.
Well, I can.
Another cup of coffee.
Okay, I know who. Darren, who are you?
I'm Darren, treasurer, KC0ZIE.
I'm on an iPad.
KE0ME Loveland.
James.
K0KN Loveland.
Glenn, I'm sorry.
K0GCB Fort Collins.
Roger.
Roger, KG0I Pueblo.
Oh, you're in Pueblo?
Yeah, down visiting family.
Oh, okay, cool. Mark?
Mark, AE0DJ Fort Collins.
The other Mark.
And I guess I'm the other Mark, Mark N7CTM Firestone.
And I'm the third Mark, K0FNL Loveland.
Jerry.
AHEE, Jerry.
Carrie.
NW0W, Jerry in Fort Collins.
Is there another Jerry?
Yeah, KHEE, Jerry in Fort Collins.
Yes, sir. Carrie with a K.
Muted.
Okay, moving along. Ron M.
Ron NW0U Fort Collins.
Okay. Bill.
Bill, AB4TC Fort Collins.
The other Bill. The other Bill. Bill Beach. You just need to hit the space bar.
Yeah, I know. I had the wrong setting. K0UT Bill Fort Collins.
Thank you, Bill. Greg and Lisa.
Greg, K0GWP Greeley.
I'm here. Lisa, KE0TDQ Greeley.
Mr. Dixon.
Jim, K6ETE, member at large.
Ted, I think there's only one of you.
November 0, Romeo, Quebec, Victor. Ted in Loveland.
Thank you, Ted. Damon.
N0FON in Holyoke.
Here we start. Let's start with the other Mike from Windsor.
KE0LCK, the other Mike from Windsor.
Any other Mike that's on?
Mike N0YLS in Livermore.
Got to be more than two of you guys. There's not. David.
David, K6OG, Estes Park.
David, WV0IXV Fort Collins.
Okay, I'm still looking through here. Then there's a Dave.
Dave, WA1JHK from Firestone. Good morning.
Rick, hi there.
Good morning, Rick, WA7BNG Loveland.
Ed.
I'm your token newbie. I'm Ed from Fort Collins. KF0 EOK. No newbie to hand, newbie to your club.
Very good. Okay, old Kodaker, thank God. I got another one. Let's see, who have I got? Luann.
K0LAO. Loveland.
Ray, I don't think I got you. Hit the space bar and unmute yourself.
Yeah, I just figured that out. Ray, W8LYJ.
Marty. Hello, Marty. Okay. Dick.
Whoop.
Yeah, there you go.
WB0 ZMX, Pinewood Springs.
Wow, thank you very much. Lisa. Lisa? Oh, maybe she's gone. Tony.
This is Tony, KD0WDX. Oh gosh, what am I? Secretary.
Carl.
Yeah, Carl, Whiskey Zero Papa Tango. I contribute my membership towards Mark, so he sent me the link. I joined up this morning.
Oh, great. Thank you very much.
Sorry, FNL Mark. I want to make sure the right Mark gets.
Okay. I do appreciate Mark and you joining us. We appreciate that. Anybody else that I probably missed because it's been moving around a little bit? Who else hasn't checked in?
K0. This is K0 PRB, Phil in Loveland.
Oh, Phil, I'm sorry. Who else was in there?
Pete, KG6 CNW up by Pinewood Reservoir.
Oh, thank you very much for doing that. Appreciate that. You're the guy that's having all the trouble with the connection. I still don't understand that.
Well, once the snow gets off the roof, I'll put that antenna up a little bit higher.
Yeah, I think that helps. The way you showed me the picture, I think you're getting blocked by the house. I think you get it up there, you're going to be dead gone. Anybody else that I missed? And I'm sorry.
This is Ann, K0ARD in Fort Collins.
Oh, Ann, I did not see you on our list. Thank you very much for checking in. I appreciate it. Who else?
K9AZA, Fort Collins.
Oh, yes, sir. Thank you very much for checking in. Who else?
This is Tom, AE3TB, Wellington.
The Windy City. According to Marty, it's bad up there, and I got to agree with it. Are you the one who told me yesterday you never see the snow hit the ground and it just goes sideways?
Exactly. It just blows down to Marty's house.
That is so cool. Hi, Marty. He's not muted. I don't know why he can't come in.
Brad, AE0KO.
Oh, thank you, Brad. Who else is out there?
Also had Lisa say her microphone's not working, but she is KF0EOS in Fort Collins.
Great. Anybody else that I probably missed?
Eric, KE0YBK in Wellington.
Oh, hi, Eric. How you doing tonight? Today.
Doing well. How are you?
It should be night. Anybody else I missed? Okay, moving right along. Officers reports. We got the newsletter yesterday or day before, I can't remember which, and I did not post it. I will post that later on today. In fact, I should have done it this morning first thing. Are there any questions about anything that's on the newsletter? Any comments about anything that's on the newsletter?
Hey, Joe, does Darren still need people for the May 8th event?
Yes, I do.
Okay, I'll send you an email then, Darren.
Yep, send me an email and I'll take that opportunity to say on May 8th, we've got Quad Rock, which is a trail run event up near Laurie State Park. I'm looking for volunteers that are willing to help out. No special equipment or training necessary. We'll take care of everything for you. If you're interested or want to know more, send me an email, kc0zie@ncarc.net. And if you're lucky, you can get one of these fancy mugs. We usually have these left over every year.
For $20, you bet.
They don't charge you. They even give you lunch.
Oh, cool. Weather spotting class, it's next Saturday. I think it's 8:30 to 9:45. It's only like a little over an hour. You can sign up on the Aries website. It's basically done from the state. It is a special, I don't know what you would call it, special training
session
for our area because of the burn scars and things like that. So even if you're not a Skywarn person, things like that, it's kind of an interesting class. It might not be a bad idea for you. Just go ahead and sign up. It's free. Like I say, it's a little over an hour. And it is what it is. Marty, you trying to get in here?
Let's see. How the hell do we do this?
Well, so far that sounds good.
Ay, ay, ay. Okay, evidently I am challenged.
You're in now.
Am I in?
Yeah, there you are.
Oh, there I are.
Good looking guy you are.
Yeah, right. I should cover that up. That's what they have, sticky pads right here. Hey, Darren, what's the particulars on that without sending an email on the Quad Rock?
Basically, it's a full day event, up to 50-mile trail run through Laurie State Park and over into Horsetooth Mountain Park. We've got 4 aid stations that we need a couple of people at each one.
What's start time?
What's that?
Start time.
Since this is it's a 25-mile loop and people can choose to do 2 loops. I have no idea why. It runs all day. So this is I think they start the race about sunup at 6:30, and it runs pretty much 12 hours until 6-7 o'clock.
Okay.
What is the date again?
Saturday, May 8th. And if the time commitment is a little much for folks, there are a couple of locations where we can set up shifts and swap out midday.
That would be good. Okay, great.
Great. Thanks for that. The Grover Project. I need to give you folks an update on this thing. As you know, we've been working on this for quite some time. And as you all also know, most of the reason is because when you deal with a government, there's a lot of signatures they have to get and various things like that. Well, I don't know when we bid this thing, but I think it was before Christmas. And we bid it at $1,700 and came to the club for $2,000. Well, we got the signatures, I think, a week ago last Monday. And we started ordering our parts and come to find out that we were a little bit short on what we figured because things had really changed. It could have been COVID, it could have been anything, but bottom line is they went way over. They went over to $3,000. So, but we have a reprieve. Jim, I'm going to turn this over to you and thank you very much for what you're doing, Mr. Dixon.
Hello, as Jim K6ET, member at large. As most people know, I'm also a member of Colorado 4x4 Recovery. We do a lot of recoveries and search and rescue operations around the state. And we're always looking at ways to expand our communications. And this came up. We happened to have our board meeting for our rescue and recovery group on Wednesday. I brought it to the board's attention and the board unanimously decided to make a $1,000 donation to NCARC to help fund the Grover project for equipment purchases and overages and costs. So there, I will get with Darren this week after I get back home and get him the $1,000 check to help cover the cost of equipment.
Jim, I want to thank you and your folks down there for helping us out with this. This is really going to be a big asset to everybody, I think. And without your help, we probably would have got it done, but this is very great, very good. Thank you very much for that.
Yeah, you're welcome. We're glad to help. And we use a lot of the repeater systems around the state and always looking to help when and where we can, especially with expansion of coverage areas.
Now I'm reading the chat. Okay. Anyway, if you don't know what we're talking about, what we've done is we've made a deal with Weld County. Roy Rudisell, who's EOC manager over there, and a ham radio guy. We actually certified him a few years ago, got him trained and all the rest of that stuff. And we are putting in a linking system on the Grover Tower, which will link an analog and a digital repeater to Sterling. Now it's going to be somewhat similar to what the 275 is to the 750. You will be linked when you get past the point that where we're linking to Buckhorn. When you get past the point where you lose Buckhorn, you can link into Sterling, and therefore it'll just go back into the Buckhorn thing. So it's a real good asset for our Skywarn people and for people just out there. It's a really big deal, I think. Unfortunately, it took a while to do it, but we got her done. Any questions about that? Okay, let's move along. James, I'm going to throw it to you for our 220 update.
So it was included in the tech report in the newsletter, but the long and short of it is the 224840 repeater on Buckhorn is back on the air. It's not in fantastic shape still. It still desenses itself a bit, but it is usable. It's not HT coverage yet, but it's certainly mobile coverage. As it turns out, the root of the problem was the Bridgecom commercial repeater we bought is just unbelievably poor design. When you take the lid off the box, there are two company I've never heard of mobile radios inside, and there is absolutely no shielding on absolutely anything. You use RG58 coax, which is leaky in itself, and there's no ferrite, no bypass, nothing. It's just all wired. All the circuit boards are bare inside. That was a big disappointment. But the long and short of it is I've been shielding it and adding ferrites. I replaced all the coax with a decent silver, with a Teflon silver plated coax and all new connectors on the thing. And I got it down to where the thing is usable. I placed it on the mountain knowing that it wasn't perfect yet, just to see if we were barking up the right tree. And sure enough, went from completely unusable to usable with a strong enough signal. So I will continue down that path of trying to figure out what we can do. And certainly will probably never pursue buying products from repeater products. Let me get that straight, because I believe they make a lot of other things that are very good. Probably will not pursue buying repeater products from that company in the future. So 22484 on the air with more improvements coming.
This is K0PRB. Will there eventually be will there be a voter on Horsetooth for that, Peter?
I'm sorry, I'm having trouble
We're
hearing
getting
you.
a lot of background. If everyone could mute if you're not speaking, that would help. And I will go ahead and mute folks now. So James, you'll probably need to unmute to answer.
Okay, I didn't hear Phil. I heard something about Horsetooth, but I didn't hear the question.
Okay, sorry about that. Is there eventually going to be a voter for the 224 on Horsetooth?
No plans to do that at this time because it is not an interconnected repeater. It's just a standalone repeater. And, you know, I would have loved to have just left the 520 repeater at Horsetooth, but when our contract got renewed and reviewed by Crown Castle and we lost all the antenna space, the tower space on Horsetooth, we're out of real estate. We can't put any more antennas up there per our contract. So we're kind of stuck on Buckhorn. And, you know, I mean, I suppose if we decided to spend the money on connecting the 220 and, you know, to the digital backbone and then buying another receiver and connecting it that way, it's possible. It's absolutely possible. But today, it is not, there's no plans on doing that. And I think, Phil, the performance of it should improve drastically once I finish getting the rest of the descents out of the machine. And, you know, it's going to be pretty expensive to attach and vote that machine. If that's really what the club wants to do, I absolutely do it. But, you know, maybe this is a good opportunity given that we have 47 folks on the meeting. If a stronger, better 220 presence is desired, please shoot me an email at techchair or techfeedback@ncarc.net and let me know. Right now, in the past couple of years, it seems like we've had less than 6 people have interest in 220. So it didn't seem like a good resource to spend a ton of money on. But if that's not the case, let me know. You know, we're here to do what the club wants to do. And if there is a better desire for that, we'll start looking into it and make some proposals.
Sounds great. Thanks.
And I'll let the club know once I get the next round of improvements made on that box. Any other questions? Okay, back to you, Joe.
Thanks for that. I do appreciate that. Darren, I don't know what the final answer was for the rosin course. What is the city of Fort Collins doing, and where are we at with that?
Well, the city of Fort Collins is debating right now. The last I had heard, which was admittedly a month or two ago, when we were still much deeper into the pandemic, was they were not planning on opening weekends for the rest of the year. Now that thinking is changing. They are debating now, so we will see. But we cannot do a rosin core unless we can hold it on a weekend when a lot more folks can attend. So as soon as that happens, we'll let you know.
Yeah, for you people who don't know what rosin core is, because we have a lot of new folks, what it is, it's a hand-on type class we'll create a project that each individual or as a group can participate in actually building something. And with course instructors there to kind of help you along on this stuff. It's more of a hands-on type thing, a couple hours, something like that. But like I said, we need to do this on a weekend and that's fine.
So for example, some of the projects we've kicked around is slinky antenna, tape measure Yagi antenna. We had a Morse code keyer project. Don't know what else. Those are some of the types of projects we're thinking about doing.
Yeah, it should be an interesting class. We've been trying to get this going for years, and we almost had it going, and then COVID hit. So, just our luck. But we will definitely keep this as a very good thing for everybody to do. I do believe. Moving on to new. Darren, are you done? I'm sorry.
Yeah.
Okay. Moving on to new news, we have a Hamlet class going on the 19th and 26th. Now, these are two separate days, 2 Wednesdays, from 7 to 9 o'clock. And the reason they are is we have like 5 or 6 topics that we want to talk about. So we will do the first 2, I believe, on the 19th, and then finish up with the last 3, I think, on the 26th, if my timing is right. So it's not 2 individual days. It's two days for the whole class. If you can't be at one, you can be at the other. For that, just send me a note at president@ncard.net. I'll get you signed up. We got 10 people already, and we've only put this out like 2 days ago. So I think it's really good. I want to turn this over to Dave, our PAO, about a multi-club event we were talking about doing.
Sorry, I had to get everything situated.
Dave
We're just
in there? I thought he was.
He's there, but he's muted.
sorry about that. Yeah, we're looking at doing a multi-club event with the Longmont club. There isn't really a ton to report at this point, but hopefully we'll have some food and some fox hunts and a lot of hams and a lot of fun. It's really all I got at this point.
Okay, I thank you for that. I appreciate that. We have got a test session going on next week. We've got 3 slots available, 4 people a slot. You can get on our website and sign up through Sign Up Genius, and it's very simple. We will take everything from beginners all the way through extras. It's a free course, and we don't really know exactly when FCC is going to start charging $35, but as of right now, we don't believe they are. So now's the time to get your license. It's going to be cheaper. Any questions about that? Okay, moving on to our last thing. May club meeting will be live for the board. We're still, like I said, we're going to broadcast this, but we wanted a dry run on all our cameras and various other things that we're going to set up at the Golden Corral. We've made arrangements to actually have that room again on the 3rd Saturday. So that's going to happen. We will be live, and hopefully we will have a very good presentation for you. I'm working on something right now. So thanks to Dave for sending me that note. Any questions, comments, or anything else for the club? Okay, let's move right along to our presentation, wire antennas. Greg, take it away.
Good morning, everybody. Take the camera off my kitty here and put it back on me. So I'm Greg, N0EMP, one of the 2 members at large, and I'll be doing a presentation today on wire antennas. For antennas in general, if you build your own antennas, you can save a lot of money. Just looking at some of the commercial vendors that sell dipoles and end-fed antennas and other wire antennas, they really want a lot of money for them, along with balance, which I'll get into a little bit. Very pricey compared to what you can build yourself and save a lot of money. If you're interested in building antennas in general for amateur radio, one of two books you should have is either the ARRL handbook, which comes out every year, but doesn't change a whole lot, so you don't need to buy a new one every year. This one's from 2018, is the last one I bought. You want to really consider either the ARRL handbook or the ARRL antenna book, which again comes out every year, doesn't change a lot, covers everything from 160 meters to microwave antennas. So it's a good resource if you want to build your own. Also, ARRL has a lot of specific antenna books for different issues like stealth antennas, wire antennas, VHF, UHF. So look through their selection if you're thinking of building antennas. Okay, so today we're going to talk about wire antennas. And I sent out an email a few days ago to membership and included it in the newsletter, some links that I'll be referring to that you might find useful. First thing you need for a wire antenna is wire. And you can go to one of the links I sent, K7 or KF7P, and you can buy some very nice flex weave wire with a very tough UV resistant jacket, or you can buy copper weld. Copper weld is a braided steel cable that's copper plated. I've had experiences with copper weld, and so have some other people, where it will rust after a few years. So I stay away from it, and so do some other people. What I use is regular house wire from the big box store, and I do price comparison between Home Depot and Lowe's because they go back and forth every now and then as to which one's cheaper. You can buy like 10-foot rolls, 25-foot rolls, 50-foot rolls, and the more you buy, the more the price goes down. I buy 500-foot rolls, and it's more expensive for a roll, but it's a lot cheaper price per foot. A partially used roll stored indoors out of the direct sunlight will last longer than we will, so it won't expire or go bad or anything like that. So I buy 500 feet at a time, and in the long run, that ends up being cheapest.
What's the description on that wire?
Yeah, it's called THHN, and I don't know what THHN stands for, but the manufacturer that I see is Cerro Wire, CERRO wire, and this is available as a solid core or as a stranded core, and I always use the stranded core. It's more flexible, and I suspect it would be less likely to break after repeated bending in the wind and things moving around. So I use stranded core.
The THHN is the coating on the around the wire, the plastic coating.
Okay, and that's part of what I was going to talk about. This has two. First of all, it's available in different colors: white, blue, red, black, green. I've tried different colors through the years to see which one doesn't stand out as much, as more kind of blends into the background. I've tried light blue against the blue sky, and I've tried all sorts of different things. I think black, all things considered, different lighting conditions, different backgrounds, I think black wire just tends to blend in the best if you're worried about your antenna blending into the background. These wires have the colored plastic PVC insulation, and then they have a clear plastic on the outside of that. So there's two layers of insulation. This wire here in Colorado with our UV, after about 2 years, that clear outer coating starts to peel off in long strips. Doesn't affect the performance of the antenna. It's a little bit unsightly. When that happens, I drop the antenna and peel the stuff off and then put it back up. The inner colored core seems to last a lot longer. And then again, I said there's solid stranded core, I use stranded. This is 14 gauge. I use this up through 40 meters, and it seems to be physically strong enough to last. For 80-meter antennas where I have a longer run of wire, I'll go up to 12 gauge wire. So that's wire. Then you need insulators. You need a center insulator. Let's assume you're building a dipole. I'll use that as a basic example. It's either going to be a flat horizontal dipole or an inverted V. You need a center insulator. You can buy insulators. You can buy plastic insulators, ceramic insulators. You can go to the hardware store or Tractor Supply or someplace like that. You can look around the electric fence section and find various plastic insulators that are designed to work outdoors and be exposed to the ultraviolet and stand up well. I cut pieces of PVC pipe and then section them to make little kind of almost flat pieces of plastic PVC, and then I drill holes in them for bolts. And that's what I typically use for an insulator for a wire antenna. So that's for, we're talking about your center insulator here. And you want to do two things at your center insulator. You want to have a strong mechanical connection that will hold up the antenna in the wind and the snow and the ice. And then you also want an electrical connection to go to your feed point, your balun, or straight to coax, whatever you're going to do. And I'll talk about that. Just soldering an eyelet to the end of the wire and attaching that right to a balun might not hold up long term. So it's better to do some type of strain relief and then have a lead, a little jumper that goes to your antenna cable or balun. So that's your center connector. You could take just a PVC end cap and you could drill a couple holes to the side and put eyelet bolts in. And that could be a center conductor that sits on top of a post or a pole. I have a PVC T right here that I glued end caps in. It's got bolts through it for support. And then it's got an SO239 socket. And this will sit on top, obviously, of a PVC mast. I built this actually. I have aluminum rod elements that are threaded into a coupling nut. And I've got a pair of elements for 10 meters and a pair of elements for 6 meters. But I could just as easily attach wire to the ends of this and use it as a center insulator and support for a wire antenna. Speaking of wire and antennas, typically 6 meters, frequencies of 6 meters and higher frequency, you're going to use solid elements because it's easy to work with and they're not that long. 10 meters, you're kind of in that in-between area. And then when you're down into the HF bands, you're for a homemade antenna, you're probably going to lean more towards wire. And looking at the chat page here. Okay, Darren has posted up those links that I mentioned earlier. So if you didn't get the links, you can look at them in the chat page there. Coax connection. Coax, you do not want to get water inside the coax. It degrades it extremely as far as its loss and efficiency and everything else if you get moisture in there. The PL259 SO239 combination is not waterproof. So if you have something like this outside, if it's just a one-day thing and the weather's nice, fine. But if it's going to be a semi-permanent or permanent installation, you need to waterproof that connection. You can get a rubbery, gummy coax seal, kind of thick paste stuff that never dries. You mold it around the connection. That's waterproof. If you want to make it easier to take apart, you put a layer of electrical tape first, and then you cover it with coax seal. That way you can cut through it and cut through that tape and peel it off cleanly. I use liquid electrical tape for almost everything outdoors, and I just put 3 or 4 coats of this on. Again, I'll start with a layer of electrical tape if I want to take it apart later. And then I just coat this stuff on there. It brushes on and dries. I'll do 3 or 4 layers of this. It seems to be working well. Your coax end that goes to your feed point. You don't have to put a PL259 on it. You can split the coax, the shield from the center conductor, and put ring terminals right on the end of the coax, and then you can waterproof the heck out of it to make sure moisture doesn't get in there. End connectors, end insulators. A dipole or another resonant antenna, if you're running any kind of power, at the far end of the antenna, you're going to get high voltage on the end of the wire. And high voltage causes corona, which sometimes at some of these big substations you can see at night and even hear it. It's like a little blue discharge coming off of sharp objects and stuff under high voltage. If I was to attach rope directly to the wire with no insulator, that corona could eat through the rope and sever the rope. Especially if the rope got damp or wet, you could have arcing and that could burn right through the rope. I've never had it happen because I always use insulators. If somebody has had an experience with rope burning through without an insulator, I'd love to hear about it. I did see a YouTube video where somebody had a wire antenna and they terminated it at a tree, and they just wrapped the wire around the tree. And there's a video of the arcing where the high voltage was burning the bark on the tree. So that's why we use some type of end insulator on the far end of a dipole. Supports, you just use rope. You can, this is regular parachute cord from the big box store. Comes in camouflage, black. If it's going to be down low or somebody could walk into it, you can use bright pink or fluorescent orange rope for support. It's nice to have a pulley system for a permanent antenna. So when we're going to have a very heavy, wet, sticky snow event like we just had, or heavy freezing rain, it's easy to drop your antenna ahead of time before the sticky, wet, heavy snow hits, and then let things melt and then hoist your antenna back up. You can have, like I said, a horizontal dipole, which needs 3 supports, center and 2 ends. You can have an inverted V, which is a center support with a feed point at the top, so you have coax running down. And then the antenna comes down at an angle on both sides and anchors near the ground. Again, if you're running power, you don't want someone to come along and touch the end of that wire and get an RF burn. So typically, you want the ends of that antenna to be above 8 feet where someone's not going to touch it. Again, if you have to throw up an antenna quickly for field use and you're going to be right there, you can modify that if you're supervising what's going on around your antenna. Let's see here. Ballons. You hear about, do I need a ballon? Do I not need a ballon? If you have a center-fed dipole that's tuned to the frequency you're using it on, it'll probably work okay without a ballon. And what a ballon does, a dipole is a balanced antenna. Coax is unbalanced feed line. And you can get a situation on the coax where you have current on the outside of the shield, which you don't want. And that can get RF back into your shack, and you might hear your own RF in your computer speakers or stereo. In a heavy, bad situation, you get enough RF on the outside of your microphone or radio to cause a skin burn. I've never seen that happen, but I don't run over 100 watts. So Again, if you need to put up an antenna and you don't have a balun, you'll probably be okay trying it without one for a center fed dipole. And then if you have problems, then you know you need a balun. The other thing a balun does for you, and I'm talking about a 1-to-1 balun here, not impedance matching, just a 1-to-1 balun, is if you're in a shack like mine, I've got a computer and video monitor in here and switching power supplies for stuff that plugs in. All that stuff makes noise here in the shack. Without a balun, that noise can follow the outside of the coax out to your antenna, get into your antenna, and come back into your radio, and you'll have a higher received noise floor. And you'll see that reduced if you install a balun. One of the links I provided was a guy with a YouTube channel, TRX Lab. It used to be TRX Bench. He changed it. And he explains in very great detail how to make various baluns and save yourself a lot of money. And he explains how they work. And I've got the numbers of the videos you'll want to watch in those notes. It was 100 and 105 and a couple other videos of his. So that's baluns. If you're going to have a balun at your feed point, you can put it in a waterproof box. This is a balun I built that's got 2 taps for, it can be a 4-to-1 balun for 200 ohms or a 4-to-1 balun for 450. And it's got mechanical support for the wire on the ends. This would go up at the feed point, and then the electrical connections are up here, and an SO239 at the bottom. I have one of these outside permanently installed for one of my antennas. So instead of an SO239 at the bottom, I used a waterproof cable fitting from the electrical section at the big box store. And I've got my coax run directly to the inside of this box, so it doesn't get water on it. And because I don't have to disconnect that there. Here's another 9-to-1 balun for end-fed wire antennas. It's not waterproof. It's kind of sort of waterproof. I could put it in a plastic bag if I had to. This is more for a temporary throw something up out in the field kind of an antenna. And I just stuck it in an electrical box with a cover on the end. Again, all these baluns are on that guy's YouTube channel. He explains baluns way better than I can. Here's a commercial insulator. It's an end insulator. Wire goes through one side, rope goes through the other. These are very inexpensive. I think I got these at Hamfest one year in the olden days when we had those things. So there's a ceramic version of this. This is plastic again. If I have them, I use them. If I run out of them and I need them, I just cut up some PVC pipe. When I make my wire sections for various antennas with wire, it seems I can set a coil of wire down on the table, lay another coil on top of it, walk away for 5 minutes, and when I come back, they're all tangled up. I don't know how that happens. So I'll make individual cut lengths of wire in pairs, write the length, and put an insulator on one end and a ring terminal on the other, and put it in a Ziploc bag. And I've got a box of these. So this is 33 foot. This would be one leg of a 40-meter antenna. So I have a pair of 33 footers, a pair of 66 footers, a pair of 17 footers for 20 meters. So I can just grab bags of stuff and a center insulator and throw an antenna together real quick out in the field. Any questions so far? Okay, I'm going to get into a couple somebody had a question.
Okay, I just want to know if I'm probably just a little bit ahead here. Are you going to cover fan dipoles by any chance?
I'm not covering the fan dipole, although I could mention it, but I'm about to get into some multi-band antennas.
All right, that's great.
Yeah. So.
Question on the wire.
Uh-huh.
What was it, the gauges again for, and the reasons why?
I go by gauge for physical strength. As far as the current that a wire is carrying, and if James is still in here, he might have some numbers. But even at 100 watts, you're only running an amp or two. And using a dipole as an example, your high current is at the feed point, is high current, low voltage. As you get up to the end, it's low current, high voltage. But even at 100 watts, you're running less than an amp. So you really don't need the current carrying ability. You do need physical strength. My big antenna outside is a 80-foot, an 80-meter horizontal dipole. So it's got 4 support points sticking up about 15 feet out of the ground in a square, and each side is about 66 feet of a square. And I use the 12 gauge THHN wire for that. And during the big sticky snow we had, 3 weeks ago, it was just covered, and the support 2x4s were bent and sagging, but the wire held up. The wire never broke under that condition. And luckily, when the snow dropped off, I was up there at 2 in the morning hitting it with a stick to knock snow off. It sprung, the 2x4 sprung back up. They didn't get damaged, luckily. So the 12 gauge held up under that situation, and that's why I use that heavy wire for 80 meters.
And normally, what gauge might you use for a 40 meter, for example, or 20?
14 gauge. I don't go below 14 gauge unless I'm trying to hide an antenna. I'll use 14 or I'll use 20 or 12 gauge. You could go lighter if you needed to help hide something.
How accurate do you have to be on the length, and where you tie it to the insulator, that part that loops back, does that count in that length?
Yes, it does. And I'll talk a little about length. There's formulas for length of quarter wave elements and dipoles, or half wave dipoles. And essentially a quarter wave length is about frequency or 234 divided by frequency in megahertz. Half wave length is 468 divided by frequency in megahertz. That is for bare wire, and it is based on how fast RF travels on bare wire. If you use insulated wire like I do, it goes a little bit slower. So I still use that formula, and it gives me enough wiggle room to trim it. And the ultimate length of the antenna is going to, in part, especially on HF, be dependent on how it's installed, how near it is to other objects, how high above the ground it is, the characteristics of your ground under your antenna. So you want to make it a little long, and then you want to test it and trim it down to length. It's easier to cut wire off than add wire. And on the end where I'm feeding it, I don't like to twist wire around and then connect the end of it beyond the twist while it's insulated, because I don't know what that's going to do electrically. So I strip the wire and fold it through and solder it, and then wrap a tap onto it. This little bit here isn't going to affect an 80-meter length of wire significantly at all. But this length of the lead in is going to be part of the antenna, so it's going to count towards the overall length. And again, you put it up and install it. Another thing with this wire, this THHN wire will stretch somewhat. So you can take brand new wire and you can install the antenna, trim it to length, and it's perfect right where you want it. And then 2 weeks later, it's off. It's going to resonate a little lower because it's going to have stretched a little bit. which reminds me of another thing. When you put the wire up, if you're using anything for a support that moves around like trees blowing in the wind, you need some kind of shock absorber or strain relief at the ends. You can use springs, or you can use pulleys and hang weights, just enough weight, like 4 pounds or so, to keep the antenna under tension, but be able to move as trees and things blow around, allow the antenna to move a little bit so you don't break the wire. But it will stretch a little bit. It'll change your point of resonance. If you're using a tuner in the shack, that'll make up the difference easily. But if you're trying to cut an antenna that's right dead on at a certain frequency, you're going to have to readjust it after a couple weeks. Any other questions? I'll go on. One wire antenna. Oh, go ahead.
Yeah, on the Ballons, on the commercially made ones, have you had any better luck with some? And I'm assuming that I'm going to exclude all the Chinese made ones. I've had some bad luck with them, but for a reasonable price, do you have any suggestions who makes a decent one for 300 watts or less?
There was a 4-to-1 Ballon that I bought that I used for an off-center fed dipole that I'll be talking about. And I think it was W2DU, if that rings anybody's bell, or someone can look that up and go, oh yeah. But I got it through Ham Radio Outlet, and it was a 4-to-1, and it was built in a waterproof PVC pipe glued shut. It had good strain relief. It had lightning arrestor on it. And I used that for years with a off-center fed dipole, and it worked for me quite well.
Greg? I'll show off mine. I do more in the way of QRP for my wire antennas. So I use speaker wire, which is thin, light, and you're only doing a couple watts. And then I just use 1/2-inch pieces of PVC that I cut and then drill a couple of holes through, and then attach the paracord to the other end. So it's an alternative to trying to cut PVC lengthwise too.
Yeah, there you go. It's a very clean looking insulator. Cheap.
Cheap, simple, easy. You cut these things, 1.5 inches long, and a 10-foot piece of PVC costs you $2.
Yep.
You got enough for a lifetime.
Okay, I want to get into some multi-band antennas now. Typically, you cut a dipole for a frequency, and if it was in free space, several wavelengths away from everything, including the ground, it would be about 77 ohms impedance at the feed point. With HF antennas, we don't get them that far above the ground, and that lowers the impedance a little bit. So the feed point impedance is going to be about 50 ohms, and that's a good match for standard coax. So if you make a dipole for 80 meters, 3.6 megahertz, it's going to be about 50 ohms. If you double your frequency, which puts us in the 40 meter band, about 7.2 megahertz, the frequency or the impedance is going to be thousands of ohms, and you're not going to get power going into that antenna. When you triple it again, now you're in the 20 meter band, and again, it's about 50 ohms. Add another 3.8 to it. Now you're in 10 meters, and again, it's going to be very, very high impedance, and power's not going to go into it. So a dipole will work on odd multiples of its base frequency that it's designed for. Because of this, there's a really neat trick you can do. You can make 2 dipoles that are, one is twice the length of the other. So they can be 80 meter and 40 meter, or they can be 40 meter and 20 meter, or they can be 20 meter and 10 meter. You put one of them up on a center support as a inverted V. And we'll say this inverted V is running north-south, for instance. You attach the other dipole, which is half the length, at the same feed point, directly connected, running 90 degrees. So it would be running east-west if your first dipole is running north-south. Then you have end insulators and ropes on the ends of the wires. The wires act in this case as antenna elements and as guy lines for the center conductor or center support, which you make out of PVC or those fiberglass poles we see at Hamfest, the 4-foot sections that stick together for military camouflage netting. There you have an antenna that you can pack into a vehicle, go out in the field and set up very quickly, that is self-guying. And if you use the 80 meter, 40 meter version, because of these multiple behaviors of the dipole, it will work on 80, 40, 20, 10, and maybe 6 meters, depending if you have a balun at the feed point. Depending on the core material of the balun and its design, it may even work on 6 meters. So that's a very simple, inexpensive multi-band antenna. And one of the ones I first started playing with after I got licensed that I've been very happy with. Any questions on that? Another antenna that I had up before I put up my loop was an off-center fed dipole. A dipole fed in the middle, like I talked about, is about 50 ohms, given ground proximity and things like that. And it does not work on odd multiples, or rather on even multiples of the fundamental frequency. So it will work on every other band, but it won't work on every band. Well, there is a sweet spot off to one side. So instead of feeding it in the middle, it's about 1/3 of the way towards the end. And at that point, it's not 50 ohms, it's 200 ohms approximately. But it's 200 ohms on every multiple, even and odd, of the fundamental frequency. So you put up an 80 meter antenna, for instance, a dipole. This could be an inverted V. I've never seen it or tried it as an inverted V. Typically, we're talking about a flat horizontal dipole, up as high as you can get. At the right feed point, about 1/3 of the way towards one end. The overall length is the same. So it's going to be, 120 feet, 136 feet rather for 80 meters. So the overall length is the same as a standard 80 meter dipole, but your feed point's 1/3 of the way towards one end instead of halfway in the middle. This gives you a feed point impedance of about 200 ohms at 80, 40, 20, 10, 6 meters. Some of the other bands we now have that are not harmonically related, it's still kind of around 200 ohm-ish. Well, with a 4-to-1 balun, which we talked about a little bit ago, and the guy on the video shows you how to make 4-to-1 baluns as well. Put a 4-to-1 balun at that feed point, and that 200 ohms becomes 50 ohms. You run coax into your shack, have a tuner or an antenna matching unit to make up any discrepancy, and you've got an antenna that works very well on most of our HF bands. Questions on that one? That was my first antenna here. And it just so happens I've got a tree out front that's about 1/3 of the way. It's right in front of my shack. And it's about 1/3 of the way from one property line to the other, which is about 150 feet. So I had room for a full size. On the one end, I have the outbuilding. On the other end of the property line, I had another tree. So I had the supports, I had everything just was laid out good on this property for an off-center fed dipole. And I used that until I put the big loop up and found out that it worked about the same. So I took the off-center fed down.
Hello?
Hello.
Hi.
Hi.
Yeah, a comment, the off-center fed dipole is an unbalanced antenna. So there's probably going to be some serious feed line radiation. So a common mode choke is really recommended with a off-center fed dipole.
Yes. And that's another good point, which the TRX lab guy goes into. A 1-to-1 balun is good at blocking that common mode current. A 4-to-1 or a 9-to-1 balun is not. So if you need to use a 4-to-1 balun or a 9-to-1 balun at your feed point for impedance matching, you want to immediately follow that with the 1-to-1 balun, which is the good common mode choking to prevent that RF current on the coax. So yeah, very good point. Okay, last thing I want to talk about is end-fed antennas. And there's two types of end-fed antennas. There's a true end-fed half wave, which, like I described earlier, if you're trying to feed a true half wave antenna, the feed point impedance is thousands of ohms and it's very difficult to match. I've never even tried to. There are commercial products that claim to do it. A friend of mine bought one and got very poor results, and I looked at it and we could never really get it to work. Very difficult to match those thousands of ohms of impedance with RF. The other type they call a random wire. It's really not random. And one of the links I sent talks about good lengths and bad lengths of wire for HF random antennas. And I had random antenna in quotation marks because it's not random. What you're trying to do here is you have a wire antenna and you're feeding it at one end. The nice thing about that is you don't need a lot of coax going to your radio. You don't need a big long feed line coming from a support coming down to the ground and running into your shack. All you need is to reach from the end of that antenna to your radio, which might just be a few feet for a field installation. This antenna can be horizontal, especially if you're in a multi-story building and you're up on second or third floor. It can run straight out. It can be an inverted L where it runs up and then out, or it can be an inverted V fed on the end. So you have a center support out in your backyard somewhere. The wire goes up from your house to the center support and runs down to some terminating support. But the feed point is right at your house. It's the end of the wire at your house. If you were to use a quarter wave wire, you'd have about a 50 ohm feed impedance there. You don't want that. If you were an exact half wave or a multiple of a half wave, you'd have thousands and thousands of ohms. You don't want that. You want a length of wire that on every band you operate on is going to be somewhere around 450 ohms. And then you have a 9-to-1 balun right at the feed point down to a ground rod, maybe a couple short counterpoise wires laying on the ground. You don't need the big radial system you do with a 50 ohm antenna. And that link I sent shows, a guy did a big spreadsheet of different lengths of wire that work and lengths of wire that don't work that you want to stay away from. And again, that's a multi-band antenna. It will work on, especially with the longer antennas, and you're limited by how much space you have and how much wire you want to run, but you get one of the longer random wire antennas, it'll work on almost every band. And again, you use a tuner to make up any deficiency in that. And again, after the 9-to-1 balun, you could have the 1-to-1 to help keep common mode current out of your shack. That's a good field antenna because you can run it right from your vehicle at one end, up a tree, and then down to another tree downrange, and throw it up real quick and have good performance. As an HF general receive antenna, I've got one in my backyard I use for receive only, and you don't have to worry about the SWR mismatch there. And I've got it as an inverted V end fed at the house, and that thing is phenomenal for just listening to AM broadcast, low frequency stuff, and the whole HF band. Questions on any of that? I'm looking around here and I'm out of props, so I think that was everything I wanted to cover.
Greg, I've got a question.
Uh-huh.
Do you prefer stranded wire over solid core?
I do. I've never done any scientific comparison, but I think the stranded would hold up better in a situation where there's going to be any kind of movement, bending, over the long term.
Greg, how do you figure out the proper impedance? Did you do that through simulation or?
No, very good question. I use that formula to cut to length. And again, because I'm using insulated wire instead of bare, I'm guaranteed to have a little bit of extra. And then I measure it. I used to use a MFJ manually operated impedance meter or SWR meter where you would turn the knob for the frequency and it had a digital display and needles. Now I've got one of the nano VNAs that everybody uses. And I built a 1-to-1 balun, which is right here. And this is the design that the TRX lab guy uses. So this is his 1-to-1 balun. And I put a couple alligator clips on one end and a piece of SMA cable with a SMA male connector on the other end. And this is specifically to clip onto an antenna after it's put up because installation will affect it. I'll install it, clip this on the feed point, and use my nano VNA to sweep the antenna and see where it's at.
Okay. Yeah, because my friend built a gutter antenna, and there was no easy way to figure out what it was going to be ahead of time.
Now with the gutter, if you watch people do roofing, typically after, before they lay the shingles down, there's metal edging at the edge of the roof line under the shingles. So there's galvanized metal nailed down, and your antenna system's going to couple into that. And then if it's a metal gutter, that's going to do what it's going to do. Or if it's a vinyl gutter or plastic that you run wire inside of, it's still going to couple into that metal that's in the roof edging. And, I'm frankly afraid of transmitting on gutter antennas because, like I told you, you have those high voltage points that can arc. And I don't know if you could start a roof on fire. I've never heard of it happening. I'd love to hear if someone has information on that, but I would be nervous transmitting any kind of power into a gutter antenna.
Yeah, he stays 100 watts or less, and he's never had any problems. But yeah.
Yeah, and if you're in an HOA, you have to do what you have to do. But that's an example where you're just feeding some metal that's out there and using a tuner to try to match it, which is fine if you have to do that.
Okay, Greg?
Yeah.
I just saw where MFJ is now making an antenna they call the HOA Buster, which specifically is made, I don't know all the details on it, to feed your gutters. And it basically assumes you're going to start at the downspout that's, close to the ground. And it's $250, so it's a little pricey, but yeah, for those of us that live in an HOA, maybe something to try.
I think you really need to bond the gutter sections together. You can't really trust, even if it's metal gutters. And you also need to consider RF exposure, especially with the new rules that go into effect shortly.
Yeah, if I was going to do a gutter antenna, even with metal gutters, unless it was that continual seamless aluminum that they can make on site, if it was sections, I would run a metal cable inside the gutter the full length and make that my fed-in, my antenna element. But yeah, and MFJ, I haven't looked at that product. I can't imagine it has $50 worth of materials in it, whatever it is, unless it's got a built-in tuner. So
no, it's got the mystery MFJ thing in a box that they won't tell you what it is.
Yeah, and someone will have a video soon enough where they cut one open and show you what's inside. And it'll probably be a ferrite core and some, it'll probably be a 9-to-1 balun or something like that. That's a good example of not paying for something you can make very inexpensively.
It's probably a resistor, and they're really selling a dummy load.
Yeah, it's a dummy load. Yeah.
Hey, Greg, we got a question on the chat about more information about your receiving loop.
The loop is actually a transmitting loop, or transceiving, transmit and receive. And a horizontal HF loop antenna is typically a square loop because it's easier to make than a round one because you only need 4 supports. I had one of my front yard trees die, and it was in the perfect spot to be one corner. So I put 4x4 posts in the other 3 spots, and then I have 2x4s going up from the 4x4 clamped on with some clamps I made out of unistrut and bolts. And that gets me about 15 feet high. And each leg is a quarter wave at the lowest frequency you want to use. And so I had room to make one that's 80 meters fundamental frequency. So it's about 65 or 66 feet on the side. The feed point is closest to the house. And I used 450 ohm ladder line down to the house because it's much lower loss with SWR mismatch. And at the entry point to the house, I have a 4-to-1 balun, but I just read an article yesterday where a guy found that a 1-to-1 balun worked a lot better for him. You are going to have to use a tuner. You might luck out and be resonant at some point on one of the bands, but it really is an antenna where the SWR swings all over the place, and you're going to need a tuner to match it. And I have a chart I made of my tuner because I use a manual tuner. So I have a chart I made of the manual tuner settings on different bands. There we go. And I'll have to make a new chart if I change that from a 4-to-1 to a 1-to-1 balun. And I've got an MFJ roller inductor tuner here with cross needles that show SWR. And I'll use antenna analyzer, or now I'll use my Nano VNA now that I have one, to make that chart, which gets me close. And things will change. When it rains, the ground's wetter, or when we have a long dry spell and it dries out, SWR and impedance are going to move around a bit. But the chart gets me close on my manual tuner, and then I just make final adjustments on a frequency I want to use.
Time for the commercial. I have a Palstar HF auto tuner for sale. End of commercial. End of commercial.
Okay. Yeah, I've got a couple auto tuners. I like the MFJ because it has the big cross needle to show me immediately if something weird happens while I'm transmitting. I could use an auto tuner and just the meter portion of the mechanical tuner, but I kind of like playing with knobs and roller inductors and stuff. So I went with the manual. But yeah, there are some. ICOM has a auto tuner where the tuner portion goes right at the feed point. And then the control cable comes down into the shack. And that is excellent because you have a good match right at the feed point of the antenna. I don't know if your Pelstar does that, but yep.
No, the Pelstar's claim to fame is that it's mechanical. It has a motor on the roller inductor and a motor on the capacitor.
Oh, nice.
But it is an auto tune, and it's a full legal limit. I replaced it with something else, so I don't need it anymore.
Nice.
Greg, a friend of mine has one of the My Antennas end-fed antennas, and what I don't get about it is it says it doesn't need a counterpoise, and that makes no sense to me.
So, radials and end-fed antennas.
This is a long wire. It's not a, it's a long wire end-fed antenna, horizontally oriented. And they claim, it's got a little balun or something right there at the feed point, but they claim it doesn't need any kind of counterpoise for it, which is really strange to me. I'm trying to figure out how that works.
Well, my understanding is if you have antenna mismatch, or if you have an end-fed antenna with no counterpoise, your coax and your radio are going to be the counterpoise. Current's going to flow on the outside of coax.
Okay.
You can avoid that by putting, and I see like a typical number I see is put 1 or 2 17-foot wires laying on the ground or just under the ground. The idea is, and this gets a little more complicated, but if you have an antenna that's about a 50 ohm impedance and you have current going into the ground and your ground resistance is 20 ohms. Well, 20 ohms is a fairly significant percentage of 50 ohms, and you're going to have a lot of power wasted going into the ground. If you have a antenna like an end-fed that's about a 450 ohm impedance, you can lay a couple short pieces of wire on the ground, and if your ground portion of your RF current is still seeing that same 20 ohms as before, 20 ohms is not a big piece of 450 ohms, and we're talking what's called radiation resistance here. So 20 ohms loss in a 450 ohm antenna is not a big deal, and that's another nice thing about these end-fed antennas. That's my understanding of the physics of it.
Whether end-fed antennas need radio/counterpoises or not is as controversial as how much power you can run with FTA.
Yeah.
Understand that AM broadcast stations that use a half wave, which are basically a end-fed antenna, have a radial system of 120 radials that are 4/10 of a wavelength long. Looking at about $200,000 to install it. I don't think they would do that if end-fed half-wave antennas did not need a radial/counterpoise to be an effective radiator.
Phil's PRB's in here too, and then I'll comment.
Yeah, Greg, I was about that end-fed My Antennas. You've seen my setup. I use that same antenna on Star Drive. And it does not need a counterpoise. It works just wonderfully the way it is. Definitely need a tuner though.
Yeah.
And I tune it from inside Star Drive there. But man, it's golden. I really enjoy that antenna.
Yeah. What's probably actually happening is, first of all, your coax and your tuner are acting as a counterpoise, because that antenna has to work against something. Half the current's got to go one way, half goes the other way. And then star drive is being a counterpoise, and it's coupling into the ground through surface area, capacitance, and everything else like that. So
Right.
you will have a counterpoise whether you want one or not. The question is, where do you want your RF going? And if you're having a problem, if you put one in and you're having a problem, you get an RF burns or a bunch of noise in your stereo, you know, throw some wire on the ground and hook it up as a counterpoise and see what the difference is. You might find out, oh, that helped. And if you're not having a problem, you're not having a problem. Then
I was also gonna test it by putting a 1-to-1 just up by the 9-to-1, and then see how it works with that to see if the coax is actually being used as a counterpoise, etc.
And there's also some lengths of wire on some bands where you might use a 4-to-1 balun instead of a 9-to-1. And that's a nice thing with these nano VNAs now, is you can just, you know, make a couple baluns with screw terminals on them, wing nuts or something, and try a 9-to-1 and run the sweep, and try a 4-to-1 and run the sweep, and see which one works best for your band you want to use. Radials. Brings me to two things. First of all, you can do a wire ground plane antenna. We did one for KE0LCK on 20 meters, so he could hit Wyoming from my hilltop for a contest. He hit every state except Wyoming because he was going over the top of Wyoming. So we got up high and had line of sight into Wyoming. So you can use a vertical wire, quarter wave. You can support it on PVC like we did. You can hang it from a tree. Do whatever you want to do. If you have radials, this is a quarter wave ground plane antenna. If you have radials off the ground by at least 3 feet, you only need 4 radials, and you make them quarter wave. They're actually tuned resonant radials if they're off the ground, away from the ground. You can use just 1 radial off the ground, and you'll be more directional. So if you want to send all your RF or most of it one way, or listen one direction more than any other, you can have 1 vertical and 1 radial off the ground, both quarter wave. If you have radials on the ground or in the dirt under the ground, you're going to have RF ground current, which is loss. It's resistive loss. You're warming up the dirt a little bit. And you want to shield the antenna from that dirt so it does not electrically see the dirt. And if you had a big copper sheet, a couple wavelengths in diameter, laying on the ground, that would work excellent and be extraordinarily expensive. The big guys running a 1,000,000 watts AM broadcast want to get the best performance they can, and they put out 120 radials as the broadcast standard. 1 every 3 degrees, and the radials are almost a half wavelength long, like was mentioned. That's very expensive to install. There's a guy called DX Commander that has a YouTube channel, and some other people on there that answer the question, how many radials do you need on the ground? And they did some actual controlled experiments, as much as you can be controlled outdoors, where they were actually measuring far field strength, more than a couple wavelengths away, and putting down different numbers of radials. And first of all, if they're on the dirt or in the dirt, they don't have to be quarter wave anymore, because the dirt is absorbing that RF before it gets to the end of the wire anyway. So it's not going to act like a resonant element if it's laying on the dirt. So there's a chart. There's a club here, Fort Collins CW Club has a website. I don't remember the exact URL, but if you Google Fort Collins CW Club or CW Group, I know Jeremy was in here. He's a member. They have a link to a chart, and they do vertical quarter wave antennas for field deployment, and they use like 8 radials, I think, or 12 radials. and they're shorter than a quarter wavelength. I don't know if they're an eighth wavelength or not, but there's a link on their website to a chart, and they show how many radials they use and what length they are for the different bands. And it's a lot shorter than a quarter wavelength. And some of the stuff I watch of actual experiments.
In the chat.
Okay, yeah, so some of the
Question in there too, if you want to look at that.
okay, let me pull that up. From what I recall, and it's a law of diminishing returns. If you have 4 radials on the ground, on the dirt or in the dirt, if you double that from 4 to 8, you're going to see a big improvement. If you double that again from 8 to 16, you're not going to see as big an improvement. You go from 16 to 32, you're not going to notice much change at all. So it's how much wire do you want to lay on the ground? Is this permanent or temporary? Is it a field deployment for a day, or are you putting something in at your house? I mean, if you're going to have sod put down on your, you got a bare dirt lawn and you're going to have sod put down and you're going to have a permanent vertical installation, you might put down 32 radials under the ground before you put the sod down. But if you're going out somewhere to throw up a vertical real quick, you might do 8 radials or 12 radials. And again, they're going to be shorter than a quarter wavelength.
Yeah, I agree with that. I agree with that. A quarter wave AM broadcast station with quarter wave radios, 120 radios, gets about around 90% theoretical efficiency. Antennas are all about efficiency. Feed 100 watts to an antenna. How much of that 100 watts actually gets radiated? So getting back to it, if you have 120 radios that give you 90% efficiency, you don't get 50% with 60 radios. You're absolutely right. As you increase the number of radios, the increase in efficiency goes down quickly. I think ARRL tends to recommend try to do 16 radials. 32 is really good, but beyond 32, you're just not getting that much gain.
Right, and that's for a 50 ohm antenna. Another way to kind of cheat is, instead of using a quarter wave vertical, use, and I've got a book somewhere, and I think they use a 3/8 wave vertical, but use a longer vertical, maybe even a 3/4 wave. That gets the RF up higher away from the dirt, and it raises the feed point impedance. So now you have a 4-to-1 or even a 9-to-1 balun at the, or impedance matching transformer at the feed point. Now you're running a higher resistance antenna, and you're going to have less ground loss for a given radial field.
Well, a quarter wave antenna, the characteristic impedance is about 37 ohms.
Right, yeah.
So you're not going to get a 1-to-1 match with a quarter wave antenna. It's going to be about, 1.2, something like that.
Right. But there's some guys that have done longer, like 5/8 wave verticals, 3/8 wave verticals, 3/4 wave verticals, and they reduce their ground loss, and they have to use an impedance matching transformer or some system, but then they they reduce their ground loss that way as well. But then you got to have a much higher element. And if you're already working on a 40-meter vertical, to try to make a 3/4 wave 40-meter vertical is going to be kind of daunting. At that point, you could do a vertical dipole instead. And yeah. Okay, I've got a question here on the chat page about the G5RV, which is a wire antenna. I got a couple of questions here. I got one on receiving loops and things, but the G5RV, I forget the numbers off the top of my head, but it's a dipole. Each leg was either like 41 or 51 feet, maybe 41 feet. And then there was a length of ladder line, which is parallel conductor. I don't have any in here to show you, but parallel conductor feed line. And the way that worked is the guy that designed it, as I recall, was originally designing it as a 20-meter antenna. But it was multiple wavelengths long at a 20-meter frequency. So I think each leg was like 3 times as long as it needed to be or something. I forget the numbers, but the length of feed line coming down, parallel feed line, was important to the antenna. It was actually part of the radiating element. It was deliberately unbalanced and would radiate from the feed line and from the wire horizontal elements, and it would work on multiple bands. And there was a specific length of wire and then a specific length of feed line. And then at the bottom of the feed line, it went from feed line right to coax, and coax the rest of the way in. And it's a multi-band antenna, and it works. I don't know that it works well. The antenna pattern is going to change radically on different bands because you're going to have vertical radiation from the feed line and horizontal radiation at the top. So it's going to be a compromised antenna. And had a question here, a guy with no microphone. What if you wanted to just receive on the loop and broadcast on inverted V? Would the loop receive best at the cut wave length and then degrade as you move across the band? My experience is yes. Would the receive antenna need a tuner of some sort or need to include another dipole, 40 or 80 meter? For receive antennas in general on HF, you don't really have to worry about SWR. The limiting factor on receiving on HF is background noise. Any modern receiver is sensitive enough. If you get enough wire out there or enough metal, gutters or whatever you're going to use, you got enough metal out there, at some point you're going to be receiving noise and signal at a certain ratio. And improving the performance of the antenna, unless you get directivity, is going to raise both noise and signal together. So at some point, it doesn't matter. And you can have a bunch of loss on receive. I've laid wire on the ground for receivers and done just well. Very low noise, very low signal, but enough to get through. So on receive, don't worry about loss, don't worry about SWR. Now, there are ways, even with wire antennas, there are ways to get directivity. If you have noise coming towards your location from 360 degrees all around you, natural noise from lightning crashes, power line noise, people with solar systems on their houses, fluorescent lights, plasma TVs, everything else, people with marijuana grows and halogen lights. You got all this noise coming in. If you can receive in just the direction you're interested in, you're going to lower some of the southern noise that's coming in from other directions. So in that case, you can get improvement in signal versus noise. But with an omnidirectional antenna on receive at some point, that's why just a good long random wire works quite well. By my using an inverted V design that has good vertical and horizontal pickup because the wire's at an angle, it's not flat to the horizon. So I'll get better vertical pickup and horizontal pickup with that. The question was about transmitting with one antenna, receiving with another. That's very common. especially on 160 meters, where some people don't have enough room for a really good antenna. They'll receive on a loop antenna, maybe a tuned loop antenna, and then transmit on some kind of coil loaded thing that they can fit on their property outside. Different antennas have different polarization, like I mentioned, and different directivity. So if you're transmitting on one antenna, one style of antenna, and receiving on a completely different design of antenna, you might have a situation very easily where somebody hears your transmissions, but you don't hear them back because they're coming in the wrong direction or the wrong angle or the wrong polarization for your receive antenna. So if you can, it's best to just use one antenna for transceiving. But again, if you can't, or if you have a noise issue and you have to have a directional antenna to get away from your noise, then you might do that. How long is my loop antenna? About 65 feet on each side. And a loop antenna is not a resonant antenna. It works by deliberately being unbalanced. You have 4 legs. And to get back to a feed line for a moment, if you have a conductor, a wire out in space with alternating current on it, it will make an alternating magnetic field and it will radiate RF. But if you have another conductor near it with equal and opposite current, they cancel each other out and don't radiate. And that's how twin lead works and parallel transmission lines, ladder line, things like that. You want to have equal and opposite currents, balance, so that your feed line is not radiating. You put up a big square loop antenna. You have 2 sides. Let's say those 2 sides are running north-south. The other 2 sides are going to run east-west. At some frequencies, the current on the 2 north-south sides is equal and opposite, and the current on the 2 east-west sides is equal and opposite. And you won't radiate on that frequency, and you won't really receive either. The idea behind a big horizontal loop antenna, big meaning a wavelength or more, is that in some ranges of frequencies, well, some bands, on 2 parallel sides of that square, you have current going in the same direction, not the opposite direction, and you get radiation. So in my instance, an 80 meter, to get there, you want about a quarter wavelength on each side at the lowest band you want it to work on. So on 80 meters, my 2 north-south sides might be radiating. On 40 meters, my 2 east-west sides might be radiating because on that side of the square, they're going in the same direction, same phase, not equal and opposite. And then they radiate. Then I go to 20 meters, it might switch back over to the other side. So not only is my SWR going all over the place, my radiation pattern and my takeoff angle going up is going all over the place too as I go to different bands. So it's a compromise antenna, but it works on all bands and works well. I'm primarily interested in regional and local communication on HF. So I don't have any towers. I have room for towers here. I don't have any towers. I don't have a spider beam antenna or any of that stuff. At 80, 60, and 40 meters, there's a phenomenon called NVIS, near vertical incident skywave. And in that case, you're deliberately radiating RF pretty much straight up. And then it hits the ionosphere and comes down pretty much straight down to about a 200-mile area. And that typically does not work at frequencies above about 8 or 9 megahertz. If you look at Terry Bullitt's ionograms, the ionosons typically shoot straight up and listen straight down. And you'll see, even though the band might be open all the way up to 10 meters, at a low angle going down to the horizon, you hit the ionosphere at a low grazing angle at 10 meters, it might come back down somewhere. Shooting straight up, you're never going to get reflection straight back down above about 9 megahertz. And that's why the NVIS bands are 80, 60, and 40 meters. And for those, you need an antenna just a few feet off the ground. So my 80-meter antenna is only 15 feet high, which is pretty low for 80 meters, but for what I do, it works. I think that's all the chat room questions I can see right here. It's not scrolling down. Yep, I think we're good. Any more questions, comments? All right. You still in here, DYU?
Oh, yeah, I'm here.
All right, I think we're done.
Just been listening. Thank you very much for doing that. Extremely informative. And I think we've got a YouTube video going out on this also. So
yeah, you might have to break it up. It's almost lunchtime.
well, there's that. Thank you very much. I appreciate that.
All right.
Any other questions for the board or anything else? If not, I guess that will conclude. Next, like I said, the May meeting will be done somewhat live from the Golden Corral, and I just got a report from Lori Hodges. We are a little bit up on what the COVID thing is, but hopefully by June we might even be able to bring everybody back into the Golden Corral. So again, no promises, but we are looking into that. Any other questions, comments? If not, thank you very much and good evening. Or the good
Hey, Greg.
Uh-huh.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.